All right, so we are going to do the calorimetry lab. I've got a couple things gathered. I've got 2 thermometers, the heating plate. I have a cup with a lid, and then this is a stir. I've placed a little metal, it looks like a pill, and when I turn this on, it'll stir it so that way it can keep our liquids moving. I have a scale, and then I also have the textbook for reference because we're going to need our specific heats, and so this has all of the chemicals specific heats. All right, so for a calorimetry lab, we have our MCAT equals Q. So Q equals MCAT. So we're going to have water and we're going to have a metal. So I've placed in here a metal, and it's just a silver metal. I don't know what this metal is. So that's a lie. I know what it is. But you guys don't know what it is. But we're going to be able to figure out what metal it is. So we know for water, mass times the specific heat times the change in temperature equals Q, which is our heat. So I've got some water here, and it's at 24.767 degrees Celsius. So this is going to be my water. So my water is much cooler. That's why I did it in blue. And my metal is sitting in boiling water, which means it's going to be about 100 degrees. And we can see that the water, it says that it is 98.9, 99. So it's pretty close. I'm actually going to turn it up a little bit to get a nice roaring boil. And that metal's been sitting in there long enough that we can assume it's the same temperature as the water. So when I put my hot metal into my cool water, what's going to happen to the cool water? So if I put a hot metal into cool water, the cool water should heat up, right? So my change in temperature, the temperature is going to increase because I'm going to gain heat. So if I know my mass, my specific heat, and my change in temperature, I can figure out how much heat it gained. For the metal, I can get the mass. I have a scale. The change in temperature, so I know my initial starting temperature because we said it's just going to be the same as the water. Well, if I add it to the cool water, how am I going to get the final temperature? What's going to happen to the metal? So the hot metal should start to cool down in the cool water. And it's going to cool down, the metal will cool down, and the water will heat up, and eventually they'll equal out and be the same temperature. So my final temperature for the metal and my final temperature for the water should be the same because when the temperature stops changing, they'll both be at the same temperature. And so whatever heat my metal loses is going to equal the heat that the water gains. So since those are the same, we can say the mass times the specific heat times the change in temperature of the water is going to equal the mass times the change in times the specific heat times the change in temperature of the metal. Now, since I don't know what the metal is, I don't know the specific heat. But I do know mass, specific heat, and temperature for water, and mass and change in temperature for the metal, so then I can just solve for C because that's the only one we don't know. So I've made a little table for you. Go ahead and copy this table down so that you can get the information. This, again, we don't know this one. This is what we're going to solve for. So copy this down, press pause, and when you're ready, press play again. Okay, now we can start filling in some information. So let's get our mass of our water. So I've filled it up in this graduated cylinder, and it looks like it is just below the 100 milliliter mark. So I'm gonna say that that is 99.6. And 1 milliliter of water is equal to 1 gram. So I can say that we have 90, let me do it in the right color, 99.6 grams. We know the specific heat already. Our initial temperature is going to be 21.6. Oh, actually I took the thermometer out. So let me go ahead and pour this in here. And we'll give that a minute while we get our other measurements. All right, my mass of my metal we're going to get afterwards because I already had it sitting in the boiling water. The specific heat we don't know, so the only thing we can get to start with is our initial temperature. So the initial temperature it has is 98. Let's say 98.1. So our initial temperature, 98.1 degrees Celsius. All right, and my initial temperature for the water, let's go ahead and fill that in as 24.3. And actually, let's change this temperature. I had briefly taken that out, so now that it's heated up, this is where it was before, right at 99. So that's probably a lot closer. Let's say 99.1. So 99.1. So change that. Okay. So now what we're going to do is I am going to take the metal out. I'm going to pat it dry real quick so that we're not transferring any extra water. And then we're going to quickly transport it into here so we don't lose much heat. So let me move this out of the way since it's going to be wet. All right. So I've grabbed it. Let's roll it around. That's good. Oop, I dropped it. There we go. Into there. And I got the stir going. And we can see on this thermometer it's already gone up. So we're going to look for it to stop going up anymore. So it got up to 28. And it looks like it's going down now. I'm going to just move this around a little bit just to make sure. And it looks like 28 was where it maxed out at. Alright, so my final temperature was 28.0 degrees Celsius. And that's also the final temperature of the metal, 28.0 degrees Celsius. And we can see even if I touch it directly to the metal, it's not going to change because it's at the same temperature as the water. The metal lost the heat, the water gained the heat. So now we just need to calculate our change in temperature. I didn't put units here. This was degrees Celsius. So for the calorimetry lab, usually when we do our change in temperature, we do final minus initial. But we know the one gaining heat is going to have a positive Q value, and the one losing heat is going to have a negative Q value. So the number is equal, but the signs are opposite. The heat lost is negative, the heat gained is positive. So I don't actually care about the sign, I just care about the value. So for our change in temperatures, we're not going to worry about final minus initial, we're just going to find the difference between them. So really we just want the absolute value. We just want to know what the difference is between my two temperatures. So I'm just going to take the bigger number first. We have 28.0 minus 24.3. And we get a change of temperature of 3.7. degrees Celsius. All right, same thing over here. I had 99.1 minus 28.0. And that's a change of 71.1. Okay. So now I can have this number for my change in temperature. Again, my specific heat, this is the one we don't know. So this is what you will solve for. This is the variable you need to isolate. And we said we would get the mass, so it's been sitting in here long enough to cool off. All right, and then we'll place it on here. And it has a mass of 57.96 grams. All right, and then this number goes in there. We got our mass of water. The specific heat of water we know, you can look it up, but we've used it a few times already. 4.184 joules per gram degree Celsius. And then our change in temperature. Solve for the specific heat of the metal. Once you've done that, go to your textbook. This starts on page 981. And then just look down your lists of specific heats. It goes on for a couple pages. So it looks like 3 pages of specific heats. Keep in mind I said it was a metal. So if you get something like helium, that's definitely not right.